Hello everyone, you're welcome to my channel. This is Isha Wilson Tutorials. Don't forget that our mission on this platform is to make the science subjects as easy as possible for all students all over the world. Don't forget to like, share, comment, and subscribe. Today we are taking a look at some questions that require application of the mirror formula. The first formula on the board, 1 over f is equal to 1 over u plus 1 over v, is called the mirror or the lens formula. Then the second formula is f is equal to r over 2. The third one is there for us. Then, and the fourth one, we have 4 main sets of formula to use in this topic, involving calculations on spherical mirrors or lens. Don't forget that there are 2 types of spherical mirrors. You have the convex mirror and the concave mirror. And there are also 2 types of lens. You have the concave diverging lens and the convex converging lens. Then one thing you must notice is this: the convex mirror and the concave diverging lens, they behave alike. What do I mean? They have similar physical properties. Don't forget, convex mirror and concave diverging lens, their focal length and object distance are always negative. We have negative focal length and image distance. They form only one type of image. The image is always vectoral, erect, or you can say upright, and diminished, reduced in size. But for a concave mirror and a convex converging lens, the focal length is positive, and they always form real images, except if the object distance is less than the focal length. Don't forget that. I repeat, convex mirror and concave diverging lens, they have negative focal length and negative distance. But concave mirror and convex converging lens, the focal length is positive. The image formed is always real, except when the object distance is less than the focal length. So let's see how it goes. Now, we have a set of formulae to apply. You must not forget that U represents the object distance, V is the image distance, F is the focal length of the mirror or lens. R is the radius of curvature. The radius of curvature is the radius of the sphere from which the mirror, spherical mirror or the lens was cut. Then M stands for linear magnification. Then HI here is the image height. H0 is the object height. Don't forget, P is the power of the lens. The fourth formula is used for calculating the power of the lens. And when using the fourth formula, your focal length must be in meters. The unit of power of a lens is diopter. Normally, the SI unit of power is watt or joule per second. But for the power of a lens, the unit is in diopter. This is how it is spelled. Diopter is the unit, SI unit of the power of a lens, or the power of a lens. So now, let's take some questions. We have about 4 questions on the board already. Please don't forget the formulae that we have to apply. Keep in mind that we have to remember the formulae. Formula is everything in physics. If you are a student and you can't memorize your formula, then it means you are not ready to be a physics student or a science student. A science student should be able to memorize formulae. That's what makes you a science student. So keep this formula in your brain, not in your notes or somewhere else. They should be in your brain. Now we take question number 1. The question reads, an object is placed 20 centimeters from a concave mirror. Take note of that. Of focal length 15 centimeters. This is a concave mirror. The focal length is positive. So we have to write F is 15 centimeters. Don't forget, concave mirror and convex diverging lens. Their focal length is positive. We are now told that the object is placed 20 centimeters from the concave mirror. That means the object distance is 20 centimeters. Now the question says you should determine the position, nature, and linear magnification of the image. Now we take position. Position means the position of the image is the same thing as the image distance. So as you can see, we are using formula 1, which is called the mirror or the lens formula. Now we have to put in the values. We are going to have 1 over 15 is equals to 1 over 20 plus 1 all over v. Then 1 over 15 minus 1 over 20 is equals to 1 all over v. Then what is the LCM if you collect items? So what is the LCM of 15 and 20? The LCM of 15 and 20, let's find out the LCM. Take your mind back to LCM. LCM of 15 and 20. Don't forget, when looking for LCM, you use only prime numbers like 2, 3, 5, 7, 11, 13, and so on. Use only prime numbers. So the first prime number is 2. 2 can go into 20. So 2 here, you have 15, 10. 2 can still divide the 10, so we keep using 2 until 2 can no longer go. You have 15, 5. Now 2 can no longer go into that. Let's try 3. 3 can go into 15. 3 here, 5, and 5. 3 can no longer go, then 5 here, 1, 1. That means the LCM is 2 times 2 times 3 times 5. 2 times 2 gives us 4 times 3, that is 12. 12 times 5 is 60. That means the LCM of 15 and 20 is 60. So now let's take the LCM. The LCM is 60. 60 divided by 15 is 4. 4 times 1 is 4. Minus 60 divided by 20 is 3. 3 times 1 is 3. It's equals to 1 all over v. 4 minus 3 gives us 1. So you have 1 all over 60 is equals to 1 all over v. Then we cross multiply. If we cross multiply, we are going to have v is equals to 60 centimeters. So that means the position of this image is 60 centimeters from the concave mirror. Then let's talk about the nature. The nature is real. Why do we say it's real? The image distance is positive. Real images are positive distances. So the nature is real. Let's take the linear magnification. We are told to determine the position. The position has already been determined, 60 centimeters. The nature is real because we have the image distance is positive. The linear magnification, M is equals to V all over U. Here V is the image distance. The image distance is 60 and the object distance in the question is 20. So 60 divided by 20 gives us 3. So the magnification is 3. Meaning the image is 3 times as large as the object. Let's take question number 2. We are going to clean off the working for the first one. So we are going to clean up the working for the first question. Let's take question number 2. We are told an object is placed 15 centimeters in front of a convex mirror. Don't forget, this time the mirror is convex and the object distance is now 15 centimeters. And the convex mirror has a radius of curvature of 20 centimeters. What does that mean? The focal length is minus 20 all over 2. That is minus 10 centimeters. Why minus? For the concave mirror, you could see that the focal length is positive for a concave mirror and a convex converging lens. The focal length is positive. Don't forget that. But for a convex mirror or a concave diverging lens, focal length is negative. So you have to attach minus there for you to get the correct working or answer. Now we have to find the position and nature of the image. So the position, let's get the position the same as the image distance. We are using the same formula. 1 over f is 1 over u plus 1 over v. Then we have 1 over minus 10 is equals to 1 over 15 plus 1 all over v. Collect like terms. You have minus 1 all over 10 minus 1 over 15 is equals to 1 all over v. Now, when subtracting fractions, you have to look for the LCM. The LCM of 10 and 15 is 30. You can try it yourself. You are going to have 30. Then 30 divided by 10. 30 divided by 10 is 3. 3 times minus 1 is minus 3. 30 divided by 15 gives us 2. 2 times minus 1 is minus 2. It's equals to 1 all over v. Then minus 3 minus 2 gives us minus 5. So minus 5 all over 30 is equals to 1 all over v. Then we have to cross multiply. We have to cross multiply. If we cross multiply, this is what we're going to have. We're going to have minus 5v is equals to 30. Then we divide both sides by minus 5. You have minus 5v all over minus 5 is equals to 30 over minus 5. So if we cancel out, we are going to have minus 6 centimeters. Now, what does this tell you? Don't forget the first image distance we got for question number 1 was positive. And because the image distance is positive, it means that the image is real, because real images are positive distances. This time around, the image has a negative distance. It means the image is visual. So for position of the image is 6 centimeters from the convex mirror, but the nature this time around is visual, and it's going to be found behind the mirror. The nature is visual because this time around we are having a negative image distance. That is it for question number 2. Let's take the third question. So take note of that. We are taking the third question. The third question reads: an object is placed 36 centimeters from a converging lens. Don't forget, a converging lens is a convex lens, and it has a similar behavior with a concave mirror. Concave mirror and convex converging lens, they behave alike. Their focal length is always positive. So f is equals to, is the focal length given? The focal length is given as 24 centimeters. And the object distance given is 36 centimeter. So we have to get let's read the question again. The question says an object is placed 36 centimeter from a converging lens. That means the object distance is 36 centimeter. Or focal length 24 centimeter. That means the focal length is 24 centimeter. If a real image which is 4 centimeter high, that means the height of the image is given. The image is 4 centimeter high. We are told to calculate the height of the object. So we are looking for the height of the object. So the first thing to do is to get the image distance. So we are still going to stick to the mirror formula. Mirror formula is very important in these calculations. Now 1 over f is equal to 1 over u plus 1 all over v. The focal length remains positive because it's a converging lens. So 1 over 24 is equals to 1 over 36 plus 1 all over v. So we collect like terms. 1 over 24 minus 1 over 36 is equals to 1 all over v. Then what is the LCM of 24 and 36? Don't forget, when subtracting or adding fractions, you just have to look for LCM. So the LCM of 24 and 36 is 72. You can try it yourself. Then 72 divided by 24 gives us 3. 3 times 1 is 3. Minus 72 divided by 36 gives us 2. 2 times 1 is 2. It's equals to 1 all over v. That means 3 times 1 is 1 all over 72. It's equals to 1 over v. We have to cross multiply. If we cross multiply, v times 1 gives us v. And 72 times 1 gives us 72. That means the image distance is 72 centimeters. But we are not told to get the image distance. This time around, we need to look for the object height. Now, don't forget that magnification is mathematically expressed as m is equals to v over u, where v is the image distance and u is the object distance. And the magnification is also image height over object height. Check the formula. That means we can equate the two formulae. You can say v all over u is equals to hi all over h naught. What does that mean? Image distance over object distance is equals to image height over object height. So let's substitute. We already have the image distance as 72 centimeters. So we say 72 over object distance is 36. So we put the 36 there. Then image height is 4. So we have 4 here all over the object height. I think what we should do now is to reduce to lowest terms. But we can do without that. So let's just cross multiply. Let's cross multiply. So if we cross multiply, we have 72 times image height is equal to 36 times 4. Then 72 times object height, I beg your pardon, gives you 72 h naught. It's equals to 144. So what do? We have to divide both sides by 72. So we divide both sides by 72. We are going to have h naught is equal to 2 centimeters. So the object height is 2 centimeters. So easy to do. Let's still take the last question, last example on the board. The last question on the board reads as follows. The image of an object is located 6 centimeters behind a diverging lens. Don't forget, a diverging lens, like we said before, a concave mirror and a converging lens, which is also a convex lens. They behave alike. They have positive focal length. Then a convex mirror, as in question number 2, and diverging lens. They behave alike. The convex mirror and concave diverging lens have negative focal length, and their image distances are always negative because they only form virtual images. They don't form real images. So the image of an object located 6 centimeters behind a diverging lens, it means V is equals to minus 6 centimeters. Why negative? Because a convex mirror, as in question number 2, and concave diverging lens, they both form one type of image. The image is always virtual, upright, virtual and upright. So since it's virtual, it's going to be negative. Then if the linear magnification is 0.6, meaning the magnification is 0.6, we should calculate the focal length of the lens. Now we are going to use this formula. The easiest formula to use in this case is M is equals to V all over F minus 1. Don't forget that the magnification is also V all over U. That is object image distance over object distance. Since the image distance is negative, it means the magnification is still going to be negative. Don't forget that. So we have to make the magnification negative because the object distance is always positive. Since the image distance is negative, being a virtual image, the magnification is also going to be negative. So let's try it. Let's put in the value so we can get the focal length of the lens. So we have minus 0.6 is equals to V all over, is equals to, I beg your pardon, minus 6 all over F minus 1. So we can collect like terms. Just move the minus 1 to the left, collect like terms. We are going to have minus 0.6 plus 1 is equals to minus 6 all over F. Now minus 0.6 plus 1. Use your calculator, you are going to have 0.4. 0.4 is equals to minus 6 all over F. Then what do we do then? We have to cross multiply. We cross multiply, you are going to have 0.4F is equals to minus 6. Divide both sides by 0.4. So 0.4 cancels 0.4. So let's divide. Make this the 6 one decimal place. So remove the decimal point, you're going to have minus 60 all over 4. 4 cancels out, you have 15. That means the focal length of this diverging lens is minus 15 cm. So that's that. Focal length is minus 15 cm. So thank you so much for always watching our videos. And please don't forget to like, share, comment, and subscribe. God bless you.